Welcome to Algebra 1, Unit 7, Lesson 4.5, Compound Inequalities, Part 1. Pearson, Algebra 1, copyright 2009. I'm Mr. Pilarski. Our objective today is I will be able to solve and graph inequalities containing and. Up to this point, we've studied solving inequalities, simple inequalities that is. Here's an example of a compound inequality with the word and. X is greater than 2 and x is less than 7. That's an example of a compound inequality with the word and. We could also write that, an alternative way to write that would be 2 is less than x is less than 7. Notice what I did here is I'm able to turn this inequality around. You've seen me do that in class or in previous videos. And since this x is greater than 2 can be written as 2 is less than x, we can write this, instead of with the word and, a much shorter way. 2 is less than x is less than 7. And the way this is written implies that the values of x have to be between 2 and 7. And we're going to see how to graph that in upcoming examples. Example 1t, writing a compound inequality. Write two compound inequalities that represent each situation. Graph these solutions. Part A, all real numbers that are at least -1 and at most 3. This part right here, the all real numbers, that gives us our variable. We're going to use a variable, and I'm just going to use x right now. And the rest of the sentence is where we get our inequalities from using x at least -1 and at most 3. So translating this, using x is at least a -1. Now, a lot of students read that as at least, they think less than, but it's quite the opposite. It's actually greater than or equal to. At least implies this is the minimum value, so the value of x has to be bigger or greater than or equal to -1. And at most 3. So x and 3, a lot of kids read that again. A lot of students of Algebra 1 read that and think most, they think greater than, and it's quite the opposite. It is less than or equal to 3. At most implies that 3 is the largest number it can be. So the value has to be smaller than or less than or equal to that number, or in this case 3. So making a number line here, we have a line with numbers on it, or without numbers on it. We're going to put numbers on it, starting at -1. And the way we graph this is x is greater than or equal to -1. So that's going to be a closed circle on a -1. And we're going to shade all numbers to the right, but also we're going to have to stop at 3. It's going to be all numbers in between. Let me show you how we change this inequality around. I'm going to take this inequality, I'm going to rewrite it as -1 is less than x. So we can overlap these x's to rewrite this as -1 is less than or equal to x is less than or equal to 3. So because I can rewrite this inequality as -1 less than or equal to x, I can write it as this inequality, -1 is less than or equal to x is less than or equal to 3. And the way it's written here, it implies that the values have to be between -1 and 3. And we use the closed circles to show that. In example B, we have all real numbers that are less than 31 but greater than 25. Similar to the last example, all real numbers is going to give us our variable x. And we have to translate all real numbers that are less than 31 but greater than x. Now, I highlight the but separately, even though it's part of this greater than 25, but that button is going to imply the word and. So we're going to have here x is less than 31. But the way this is worded implies this is an and relationship. That has to be this and this to be true. The second part of this greater than 25 translates into this math sentence. And if we rewrite it as we did up here, with the smaller number on the left, in this case the less than symbol, x, and the less than symbol again with 31, we have 25 is less than x is less than 31, which implies again that the value of x has to be between 25 and 31. So making our graph, in this case we'll use an open circle on the 25 and an open circle on the 31, and we'll shade in between because we need those values in between. We'll make it true. Example 2t, solving a compound inequality containing and, solve and graph the solution. In previous lessons, we have seen simple inequalities that had one inequality symbol. Now we're starting to encounter compound inequalities that have two, and up until this point, we've used the properties of inequality to balance the inequality. Whatever you did to the left, you do to the right. In this case, we have three parts. We have the left of the inequality that has the 5. We have the greater than symbol. And in the middle, we have 5 minus 3f, the second greater than symbol, or the second inequality, and the number 2 on the right-hand side. The goal is still to isolate the variable, in this case, f. But whatever we do to the middle to isolate f, we also have to do to the left and to the right. So to start to solve this problem, we have to subtract 5 from the middle. That'll leave us the negative 3f. Bring down the inequalities at this time, and now we're going to go back and subtract 5 from the other two parts. 5 take away 5. That gives us 0. And on the right, 2 take away 5 is a negative 3. The next step to isolate the f is divide by negative 3. So whatever I do to the middle, I also have to do to the left and to the right. Remember, when you divide by a negative, in this case a negative 3, to leave us f in the middle, remember when you divide by a negative, you have to turn the inequality around. So the greater thans turn into less thans. 0 divided by negative 3 is 0. And negative 3 divided by negative 3 is negative 1. So this is our solution. The value of f has to be between 0 and negative 1. So when we graph that solution, make a pretty easy number line in this case, 0 and, well, this actually should be the negative 1. Negative 1. Actually, this should be a positive 1. I miswrote there. That should be a positive 1. So this would be 0 and a positive 1 here. Open circle on the 0. Open circle on the 1. And we'll shade in between because that's what this implies. So that's how we solve that kind of compound inequality containing and. Even though you don't see the and, if you see an inequality like that, you can assume that it uses the word and. Example 3t, we have 2x plus 5 is greater than negative 10, and 4x minus 8 is less than 6. In this case, we have a compound inequality and we see the word and. Therefore, all we have to do is solve two separate simple inequality. So on the left-hand side, we have to solve 2x plus 5 is greater than negative 10. We do that by subtracting 5 from each side. That'll leave 2x is greater than negative 15. Next, I'll divide each side of that inequality by 2. That leaves me with x is equal or greater than negative 7.5. Bring down the and. In this case, we have two separate inequalities, so we have to use the word and. On the right-hand side, I solve this inequality by adding 8 to each side. On the left, the 8's go away, leaving me 4x is less than 14. Dividing each side by 4 next. The 4's on the left divide out, leaving x is less than 4 goes into 14 3 times, so that'd be 3 and 2/4, or 3.5 times, 3.5 times. So this is our solution. We can rewrite it as negative 7.5 is less than x is less than 3.5. And to graph that is pretty simple. Negative 7.5 on the left of the graph and a 3.5 on the right of the graph. We'll use open circles in these cases because that's what the problem was given with. And we shade in between. So those are our solutions. So when you're solving compound inequalities that contain and, you just have to remember the basic properties of inequalities, and once you get your solution, to write it both ways and to graph it. This has been Mr. Pilarski for solving compound inequalities containing the word and. Thanks for watching. Bye-bye.